To get x squared from the expansion of 1 plus x over 5 to the powers of n, r is equal to 2. Then I put into the formula NCR, NC2, a to the powers of n minus 2, b to the powers of 2. And NC2, the number from here is 1 times x squared over 25. Okay, and this term is equal to 3 over 5 x squared. So now focus on the coefficient only. I can ignore the x squared. So NC2 is n factorials over n minus 2 factorials times 2 factorials times 1 over 25 is equal to 3 over 5. N factorials is n times n minus 1 times n minus 2 factorials over n minus 2 factorials times 2 factorials is 2 is equal to 3 over 5 times 25 over 1. So cancel this and also this, 5. So n times n minus 1 is equal to 15 times 2. N squared minus n minus 30 is equal to 0. Factorize to get n. Then n is equal to 6. Next, expand this binomial, the first 3 terms only, and expand this binomial. This is easier because the exponent is only 2. And then multiply between the 2 binomials to get the term independent of x. The term independent of x is the term that has x to the powers of 0 or constant. Based on the binomials given, so the term that has x squared, the r is 2, and x cubed, the r is 3. So the term that has x squared is nc2 times 1 to the powers of n minus 2 times 3x to the powers of 2, and I add by the term that has x cubed, and c3 times 1 to the powers of n minus 3 times 3x to the powers of 3. And c2, I can ignore this, times 3 squared is 9 x squared, but I don't need to write down the x squared because I only focus on the coefficients, plus, and c3, I can ignore also this, times 27, and this coefficient is equal to 675. So I divide both sides by 9. I have nc2 plus nc3 times 3 is equal to 75. And then nc2 is n factorials over n minus 2 factorials times 2 factorials plus n factorials over n minus 3 factorials times 3 factorials times 3 is equal to 75. So since you know that n factorials is n times n minus 1 times n minus 2 factorials, so actually I can cancel this and this, right? So now I have n times n minus 1 over 2 factorials, which is equal to 2, plus same thing with this n factorials is n times n minus 1 times n minus 2 times n minus 3 factorials, cancel with this one, over 3 factorials is 3 times 2, and times 3 again is equal to 75. So I can cross this 3. Now I have n minus 1 over 2 plus n minus 1 n minus 2 over 2 is equal to 75. I don't like working with fraction, both sides multiplied by 2. I have n, and then I expand the numerator, n square minus n plus n square minus n times n minus 2 is equal to 150. N square minus n, I expand again, plus n cubed minus 2n square minus n square plus 2n is equal to 150. I arrange one more time. N cubed minus 2n square plus n minus 150 is equal to 0. So now here is the polynomials with the highest exponent of 3. How to solve these polynomials? Grade 9 lesson, remember? So you factorize trial and error to substitute n. That makes the expression is equal to 0. Then you factorize n minus 6. You will get n minus 6, n squared plus 4n plus 25 is equal to 0. So from here you will get n is equal to 6. Okay, now let's find r from the binomial expansion. NCR, I know n is 10 CR, a, which is 2y over x to the powers of 10 minus r, times b, negative x squared over y to the powers of r. To get the terms that has x to the powers of 11 over y to the powers of 4. Okay. Now I have two variables, x and y. Now I want to choose x only, so I focus only on x. So it means I can ignore this, I can ignore this, I can ignore this, and this, and this. So now focus on the x only, x to the powers of negative 1, because this x is in denominator, to the powers again of 10 minus r, times x squared to the powers of r. Index law set exponent with exponent, I multiply it, negative 10 plus r times x to the powers of 2r, and then again index law, I combine the exponent into 3r minus 10, and this must be equal to x to the powers of 11, that actually from here. So now you see this is the exponential equation, same base number, 3r minus 10 is equal to 11, 3r is equal to 21, and r is equal to 7. And then finally I substitute back the r is equal to 7 into the binomial theorem formula to get the coefficient of the specific term.